Hi, everybody. What we're going to be doing today in this video is we are going to be following along, pausing as these activities are presented, and completing lesson 1.2 together. So here I am in Google Classroom. We're going to go down to this light waves unit, and we're going to go to light waves lesson 1.2. So let's make this a little bigger for everybody. So here's the instructions. Watch the video instruction, the lesson instruction video below, and pause the video throughout to complete the activities as they're shown. That is this video that you're watching right now, folks. You'll see this lesson has 4 parts in Amplify. Part 1 is our warm-up. Part 2 is a video discussion that I'll lead you through. Part 3 is a hands-on activity with its own separate video down below here. And then part 4 is the homework question in Amplify. Before we dive into Amplify, though, I do want to share with you, I put in here this file. It's our light waves, key concepts, it's our questions, key concepts, and our vocabulary. So let's just check this out real quick. Eventually, there we are. So here's our big unit question. This is the question we're going to be answering in the next 4 chapters of study. And that is, how does light interact with materials? Our chapter 1 question, this is a question we're going to start investigating today, is how does light from the sun cause skin cancer? That's a typo. That's not how you spell from, Mr. Roberts. Anyway, the other questions for the other chapters are here. We'll go back to this document at the beginning of each chapter. But literally, if you know all of these things, all of these key concepts, you should be good to go for the test. This unit is a little lighter, I think, in the test questioning. So you're not having to figure out, like before, which way is the force going? Okay, now I have to think backwards and go the opposite way. So there's a lot less of that. Today, we're going to be covering these 2 key concepts. The movement of energy can be tracked by observing the changes the energy causes to matter. Okay, so that would be like shining a light on a material and seeing how it interacts. The other key concept is light carries energy that causes materials to change. And I really wish this key concept said all light, because all light carries energy that causes material to change. So I just wanted to share that with you. Also, down at the back here, the very bottom of this document, are all of our vocabulary words along with definitions. So this is a great resource for you to refer to in the future. Right now, though, we're going to dive right into this lesson. So you're going to click here on this link. That will prompt you to sign in to Amplify. I'm already signed in, though, so it's just going to take me right to our warm-up. Okay. So, light from the sun. The sun causes changes to things on Earth. Think of an object you have observed before and after it was left out in the sun. Describe how it changed. So, right now, I want you to pause the video, and answer this question. Once you're done, unpause the video, and we'll go to the next part. I mean it. Pause the video and do it. All right, so hopefully you paused the video and you've completed this. You're ready for the next part. So this next part is actually a video, and I will go ahead and play that in here. If for whatever reason it doesn't work for you, I did include it here. And so in this video we're about to watch, we're going to learn what a spectroscopist does.
I'm Dr. Desiree Whitmore, and I'm a spectroscopist and a professor at Irvine Valley College in California, where I teach about light and the devices and technology that use it. that you might be familiar with is the way that light can be used to warm things up. For instance, here at the beach, I'm surrounded by sand, and this sand can get very warm from the sun. So if I take my shoes off, I might burn my feet because it's really hot. Another example you might be familiar with is people at the beach laying out to get warmth from the sun. Well, unfortunately for me as a spectroscopist, I can't just sit out in the sun all day to study light. I've actually got to go into a lab to see how light interacts with different materials. So now we're going to make white light, so I need you to install this blue laser. So here you can see the blue laser. In my lab, I use a special technology called a laser, which generates a concentrated beam of light. I use the lasers to study how light affects different materials. Even our bodies and objects around us emit light. This is a special camera that can detect that light. So now this camera is measuring the light that is coming off of my body. On the screen, you can see red represents warmer temperatures and blue represents colder temperatures. I can also use light to study gases. Here I have 3 different tubes filled with gas. When I run electricity through these tubes, light gets put out. Similar to a neon light that you would see in a store, except these are different gases. One way that I study the gas is to use a special tool called the diffraction grating. When I look through the diffraction grating, I can see the light from the gas tube being split up into its different components, and that gives me more evidence about the material in the tube. One of the great things about light is that it's all around us. Everywhere you look, you can think about the science of light. Light and the technologies that use it are exciting fields of study. We need more light scientists to join the field and carry us into the future with new and innovative technologies.
All right, friends, thanks for watching that video. Let's keep watching this video. You just watched a video within a video. How crazy is that? So what we're going to do, again, going back to our unit question, which is, how does light interact with materials? And our chapter question, how does light from the sun cause skin cancer? So we're talking about the interaction of the sunlight and skin. And we're using cases of skin cancer to do that. So back over here in Amplify, we're going to dive into this little world map. First, I do want to check something in here. Okay, so here is our, oh no, I wanted it bigger. Thanks for hanging with me. All right, so when we're looking at this map, what this map is doing is it's showing us rates of skin cancer or incidences of skin cancer around the world. And you'll see there's some places that are relatively low, and that would be this light tan color here. So places like that would be here in Africa, in Asia, Indonesia, even down into New Guinea. And as we go up, we can see that different areas have different rates of skin cancer. Which areas on here have the highest rate of skin cancer? Yeah, hopefully you said Australia, right? It really sticks out on this map. There's also a few isolated places here in Europe. So our investigation question has to do with Australia for this first chapter. 2 out of 3 Australians will be diagnosed with skin cancer by the time they are 70 years old. That makes Australia's skin cancer rate the highest on the planet. On behalf of the Australian Health Alliance, I am asking for your help in educating Australian citizens about why the skin cancer rate is so high in our country. To begin your research, you'll need to learn more about what causes cancer. Good luck. Oh, that's our key concept. I already shared that with you. Let's get out of that one right there. So, that's our underlying question. This is our map that we're going to continue to refer back to. So we've already discovered Australia and these few little places here in Europe have the highest rates, and that the lowest rates are in Africa and Asia. And so I'll just pose this question. What ideas do you have about the different places that have higher rates of skin cancer? Think about it for a minute. So I'll share some of my thinking with you. You know, I would say places that typically get more sun would have a higher likelihood of skin cancer. But I'd also say that areas of the planet that are populated by people with lighter colored skin would be areas that are more susceptible to skin cancer. And I don't want to give away. I don't want to go too deep. So that's all the thinking I'm going to share with you on that before we move on to our next activity. Our next activity is actually a hands-on activity. So there are 4 little tabs down at the bottom here. This first tab is energy, and that's the definition. The ability to make things move or change. Okay, so that's what we are defining energy as. For part 4, if you go all the way down to the bottom, there's another word we're just going to cover now, and that's light. It's a pretty important one for light waves, right? And that is a type of wave that carries energy from one place through another, even empty space. Okay, so it's just a wave that carries energy from one place through another. That's our definition that we're going to use for this unit. Now, I clicked over here to tab number 2 because this is where your hands-on investigation begins. So it says, shine the light on the liquid crystal. Did you observe evidence that light carries energy? Yes or no? Describe the evidence that you observed. Use complete sentences, folks. Shine the flashlight on the solar panel of the solar-powered toy. Did you observe evidence that light carries energy? Yes or no? Tell me why. Compare the temperatures of the 2 thermometers. Did you observe evidence that light carries energy? Yes or no? Tell me why. So we're really just proving that claim that light carries energy and that light can change materials that it interacts with. Now, you don't have the thermometer, right? You also don't have the liquid crystal sheet, and you don't have the solar-powered toy. So here's what you're going to do. You are going to pause this video, and to complete the hands-on activity, you're going to go back to Google Classroom, and you're going to watch this short video of me going through the hands-on activity, and you're going to use this video now to help you answer these questions. And before I tell you to pause and do that now, I'll just say this is the end of this video because the last prompt is a homework prompt. You're going to agree or disagree for all 4 of these statements, and then choose the statement that you're most not sure about out of statement 1 through 4. And then why do you agree or disagree with the statement you chose? Explain your thinking. Okay, so I'm going to leave you at that. Just remember, for your hands-on video, this video will not do it. You actually have to stop it now and do the hands-on video, complete the homework section, and then you are all done with this lesson. Nice job.